All right, so today we're going to start talking about translating verbal sentences into algebraic sentences. So a huge part of this lesson has to do with communication. Communication is important in all aspects of life. When we're dealing with any subject, it's very important that we understand how to communicate using the appropriate language. So if we're talking to someone and we're not necessarily understanding what the other person is saying, it doesn't matter if we're both talking about the same idea. If we don't understand the words that are being used, we may miss something. We may not fully understand what's going on. So understanding the appropriate vocabulary and what it means, and really the expectations that come with some of that vocabulary, because that's a big part of math, is going to make a big difference. So I have a little joke video on the next one. For some reason, I have a theme going this semester with little videos.
What we've got here is failure to communicate.
All right, so just a little silly thing. I don't know why I like that guy's voice. It's kind of that old westerny, high-pitched southern voice there that I like. All right, so we're going to take a look at this notes page and just fill in this graphic organizer. To understand and translate a verbal sentence into an algebraic expression or equation, we need to understand what the vocabulary is and what is expected with the specific vocabulary word. So let's fill out the organizer below with some of the common vocabulary for each type of operation. So hopefully we can see there's a big plus sign, minus, division, multiplication, equal sign, and then there's this little spot at the bottom that says words that mean reverse the order. So we're going to fill this in and with our basic words. So the first one for addition, hopefully we know plus, add, or addition, because I've already said that a few times, increased. You can also say increased by. Total. So if I say, what is the total of these two numbers? I'm telling you to add. Combined. What is the combined amount, or even combined total? I've heard those together too. Sum. Now I have that one bolded and in kind of goofy lettering here a little bit, because that one's a big one that the books and Alex and math teachers, we like to use that word. What is the sum of the two numbers? Or the sum of the two numbers. That means that we're adding. As soon as I hear the word sum, I'm adding. So that's definitely a big one that we should pay attention to. And it means when I hear sum in a word problem, what it means is the next few numbers are being added. So if it says the sum of blank and blank, those two numbers are being added. I have to know that it's a quantity. The next two are kind of together. All right, so now we're going to go to subtraction. So hopefully we know subtract or subtraction, minus, decreased, decreased by. You can also have that word there. Less than, difference. So that one didn't bold quite the same. It was supposed to bold just like sum did. Difference, that's the same idea. That's that word that's used very often in the math books, in Alex, during state testing. You're going to hear those words more often than these other kind of not simpler words. They still mean the same thing, but a lot of the time you hear sum or difference instead of add or subtract. So you just have to get used to that difference as we're moving forward in math, that you're going to hear those words more often. So again, if I hear the difference of, I know the next two numbers are being subtracted. All right, we're going to move down here to division. So I can do divide or division, either one. Per or each, that can also mean to divide. Half, so if I hear half, that means I'm dividing by 2. That's a very specific division. Whoops, I don't know why I did that. Quotient, so again, I don't know why they're not bolding the same. I guess I need to fix that, because they were all supposed to bold with that fun little font there. So quotient, that means that I'm dividing. The quotient of, the next two numbers are being divided. So that's another very common mathematical word. You really only hear that in mathematics or dealing with numbers in some way. You're going to hear the word quotient. So that's a very specific word to math. But it will come up in math class, math book, Alex. It's going to come up on the state testing. It's a common word. All right, so I'll stop saying those same things over and over again. All right, so let's go to multiply or multiplication. So multiply times twice. So this is kind of like half, but I'm multiplying by 2. So if I hear the word twice, I know automatically I'm multiplying, and I'm multiplying by 2. Triple, I don't know why that popped up so quick. So triple, that's another one that comes up. I've also heard quartered. I didn't put that one on here, but for division, I've heard quartered before. And that means to divide by 4. Or thirds, divide by 3. So understanding those words as well. But twice and triple, those ones have come up. That's why I made sure they were on here. Per or each can also mean multiplication. Okay, so that can be a little confusing because we have per each in both multiplication and division. It depends on how the words are being used. So if I have something like a silly equation, like there are 4 bunches of bananas, each bunch has 5 bananas. How many bananas are there in all? Well, if I have 4 bunches and there's 5 in each bunch, I'm using each as a multiplication word. So I'd go 4 times 5 and I get 20. There's 20 bananas. But if I said that I have 20 bananas and each bunch of bananas has 5 bananas in it, how many bunches are in each bunch? I know that sounded funny. That was very wordy. That each is being used to divide. I already know the total and I'm going back to one of the pieces. So it really depends on how the words are being used. But if a lot of the time, if you have the 2 smaller parts, you're going to multiply. And if you have a larger part and a smaller part, you're going to divide to kind of come back to one of the smaller pieces. So again, it's just paying attention to how is it being used. Think about the situation and how you would kind of interpret that. All right. We also have the word product. That's that kind of big important one, like I've been pointing out. That's the word that's going to be more the vocabulary specific word for mathematics. So let's see, we have only a couple for equals. It's either going to say equals, equal to, something like that. It'll use the word equal or is. And there may be other words with equals and is, but as soon as you hear equals or is, that means equals. All right, so those are definitely important ones. And then words that reverse the order are than and from. So subtracted from, like if I hear the word subtracted from in an equation, and we're going to practice that on one of the problems here in just a second, or expressions, I have to reverse the order because it's being subtracted from a number, and so it's going to give it to you out of order in the problem. And you'll see exactly what I mean by that in just a moment. But than and from, those are the 2 words that we want to watch for because it tells us right away, reverse the order, and it's only in subtraction. And well, division problems, I think also. I think more than likely it's going to be subtraction is where we hear it from though. All right, so let's go ahead and practice. So we have translate this sentence into an equation. 49 is the sum of 13 and Chrissy's score. So you always want to read the problem more than once just to make sure that you've heard everything. The first time you hear it, when we read it, it's just kind of, we're gleaning information really quick. So we have some numbers here. I have an operation word. There's Chrissy's score. So I just get some basic information. The second time I read it, I want to be a little bit more specific. So 49 is the sum of 13 and Chrissy's score. Okay, so now I know I'm paying attention. Sum, I'm going to do something with the next 2 numbers. Well, I'm only given 1 number. But if I read this next sentence, use the variable c to represent Chrissy's score. Okay, Chrissy's score is a number. I don't know that number yet, right? So now I can start to identify on the third read all of my pieces. So 49, I'm just going to bring 49 down, that's already there, is, whenever I hear the word is or equals, it's an equal sign. The sum of, so the sum of, I really only needed the word sum, but it's in a sentence, so the sum of means add the next terms, right? So I have 13 and Chrissy's age. Those are my next 2 terms. So here's 13 and Chrissy's age, and I'm adding. I do need to fix this because Alex won't accept the words Chrissy's age. It won't even let you type that in. You're going to have to fix that because we need to change Chrissy's age to C. That's what it asked us to do here. It's not asking us to solve this equation. It just said translate it. So we're done. We don't have to solve this. If you want to, you can always solve it by using that one step. Subtract 13 from both sides to see what was Chrissy's, that shouldn't say age, that's its score. What was Chrissy's score? All right, so on the very next one here, we have translate the sentence into an equation. So same thing, 9 more than the quotient of a number and 4 is 2. So this one, there's not a lot of context here. Like we at least had a person here, Chrissy. This one is, it's a scenario. It's definitely an equation here, but we don't really have any humanity kind of inserted in there. There's nothing, no people there. So we just need to kind of break it down. What are they asking us to do? So 9 more than the quotient of a number, and 4 is 2. So I can see is 2. I know what it's going to equal. 9 more than, this has to do with we're adding. I'm giving it 9 more. Quotient of, so that's another piece I'm going to have to break apart. So we have 9. They didn't give us the number on this one. For whatever reason, they wrote out 9 here, and then they put 4 and 2 on the end. So Alex is not always consistent with that, and that's on purpose, because they want you to be paying attention to the words, not just grabbing the numbers. Okay, so they're doing that on purpose, to see if you're fully paying attention. So 9 more than, well, that means adding, so I'm going to put addition simple. The quotient of, that means I'm dividing the next terms. That's what quotient of means. So the next terms is a number and 4. So I have a number and 4, so I'm dividing these two. Is, and 2 is already underlined there, so I need to fix that little animation, but that's okay. So is 2. So here's my basic equation, but we need to make sure we read what variable am I supposed to be using for a number. So use the variable b for the unknown number. So instead of a number, they want us to use b, so I'm just going to replace a number with b, and there we go. I have my equation here. Alex may give you a bit of grief on this one if you don't put the division in parentheses, although order of operations says we would have to do the division first anyway, so it may also not give you too much grief about that. Okay, so now we're going to try this third one, and with this third one, we're going to translate it, and then we're going to solve it. So we're going to practice the 3-read strategy, a little bit heavier on this one. We've been doing that where I've been having, talking about reading it first. Do we understand the problem? Read it again. What are we expected to do? And then read it a third time and break it down. That's the exact same idea we're going to do here. We're just going to go a little farther with it. So first, on our first read, we're just going to decide, do we understand the story? Can we draw a picture? Can we picture it in our minds? You don't always have to draw a picture, but can you picture it? So Juan currently has $48 in savings. He had been saving $6 each week. Yesterday, he spent $90 of the savings. For how many weeks has he been saving? So there's a lot of information there, but can I just picture the basic idea here? I have a person named Juan, and he's saving money, and I picture a bank when I'm thinking about saving, so that's my little bank. So that's my very basic idea. I can picture this person, Juan, and he's saving money. On the second read, we want to just try to focus in on some of the details, and specifically, what are we being asked to find? Because that's a big part of understanding the word problems and the mathematics in general. What am I being asked to find? What should I focus on? How should I find that? So if we read it again, Juan currently has $48 in savings. He had been saving $6 each week. Yesterday he spent $90 of the savings. For how many weeks had he been saving? So the question, usually it appears at the end, which is nice. They usually always throw it at the end. It's, as we get more advanced in the mathematics, it might not always be at the very end. You might have to kind of figure out what the question is. What am I being asked to find? But for now, it's pretty straightforward. How many weeks has he been saving? So this is our question. I want to know how many weeks he's been saving that $6. So the third read, we're going to determine the important information. So Juan currently has $48 in the savings. Well, that's important. That's an ending point, right? That's right now he has $48 in a savings account. That's definitely an important word or important information. So here's my $48 in the savings. He's been saving $6 each week. So that's another very important piece of information. I'm going to add $6 each week because he's saving it, right? So each week plus $6. Yesterday, he spent $90 of his savings. So, I don't know why that says current total. That's silly. That shouldn't be popping up there. So this down here, it shows minus 90. So ignore that current total. I need to delete that. I'm not sure why that's popping up there. So $90 spent. That's why it's negative. He's spending it. It's gone, right? So I'm just kind of throwing these numbers on here on my little picture to kind of give me an idea. So what we want to do for part A is write an equation that could be used to answer the question above. How many weeks has he been saving? So first we're going to choose the appropriate form. It's either going to be addition or subtraction. If you notice they're identical, but we have to choose. Are we adding or subtracting something? we're spending money, so that's a pretty good clue that we're going to be subtracting. And then we're going to fill in the blanks with the numbers 48, 6, and 9. Let W represent the number of weeks. So if we go over here to this guy, oops, darn it. I don't know why it keeps going backwards. Stop doing that. Okay, so we're going to think about it just for a second. So if we think about this, if Juan puts in $6 for 1 week, what will his bank account total be? So I'm assuming they didn't give me a beginning. They gave me a current. They gave me how much he spent and how much he's saving. So I'm assuming if he starts saving at week 1, he'll only have $6. So this is my assumption because they didn't tell me any other starting point. So I'm assuming 0 is his starting point. And then what I want to kind of figure out here is what total are we trying to get to? It's not 48 and it's not 90. So keep that in mind. I'm not actually trying to get to 48 when I add 6 or for each week, and I'm not trying to get to 90 either. We're trying to get to the combined total because he has 48 right now. He had 90 to spend, so he had it all together at one point, right? So I want to know what is the combined total. The 48 plus the 90, and that's $138. That's the number I'm trying to get to when I'm looking at savings per week. So if I look at week 2, well, 6 times 2 is 12, so that's definitely not 138. Week 3, that's 6 times 3 is 18, so that's not 138. So is there a pattern here? Well, yeah. I need to find out how many 6s it takes to get to 138. That's my pattern. So let's look at this a little algebraically instead of kind of the think it through. So if we write the equation here, I know I'm going to be subtracting. I'm taking 90 away. Okay, so he spent the 90. And I know he's saving $6 per week. Remember, they asked us to use W for week instead of weeks for week. So $6 per week. And we're taking 90 away from that. And our total is $48. Right now in the bank, Juan has $48 or wherever he's saving it. So this is our equation. And we're going to solve this. So I'm going to show you, we're going to come back to this 138 right now. So now I'm going to look at this and go, okay, well, it's 6W minus 90 equals 48. And I want to know what is W. How many weeks did he save to get this amount? So we're going to add 90 to both sides because I want to undo that subtraction. I want to know what did he have saved before he spent the $90. So we're going to add that to both sides. So 6W comes down. Negative 90 plus 90 cancels out. Any number minus itself is 0. 48 plus 90, well, there we go. We get the 138. So this is how much he had before he spent any money. So now, if I want to know, well, how many weeks did that take? I'm going to take this 6 that's being multiplied by the W, and I'm going to divide on both sides. 6 divided by 6 cancels, and we get 23. So he was saving for 23 weeks to get that amount of money, to be able to spend $90 and still have $48 left over. All right, I think that was it for this one. So that was practicing translating verbal sentences into algebraic sentences, and then using that equation to solve a problem or solve for a variable. So I hope that helped, and I will see you in the next video.